Hi guys, in this video we are going to discuss all about triangles, some key information such as interior and exterior angles, Pythagoras theorem, sine law and cosine law. So let's get started. But before we get going, first of all we ought to know how many different types of triangles exist there. So this is an equilateral triangle. It's called equilateral because all the three sides have the same length. You can notice the equality of length by these three ticks. All these three ticks are the same, so they indicate three equal sides. And then we have the isosceles triangle. In this case, only two sides are equal to each other. The third is of a different length, so hence there are only two ticks. And then we have the scalene triangle where all three sides are of different lengths, hence there are three different ticks. Now this was so much about the lengths. How about the angles inside the triangle? So the first one is called the right-angled triangle, and as the name suggests, it must contain a right angle or a 90-degree angle. Next is called the acute-angled triangle. In this case, all the three angles are acute. Now, what is an acute angle? It's an angle less than 90 degrees. And finally, we have an obtuse angled triangle. And in this case, one of the three angles is obtuse. That is, it is greater than 90 degrees. So I hope that makes perfect sense. And armed with that knowledge, we can head over to the next topic, which is the sum of interior angles of a triangle. So this is a very simple identity or a very easy rule of thumb. So A, B, and C mark the interior angles of this triangle on screen. And the law says that if we sum up these three angles, the sum total will always be 180 degrees. Now, these are all interior angles, but perhaps this is a good time to also introduce the exterior angles. So we can mark exterior angles. Let's focus at the angle A here. Now, notice the angle is formed by two lines. So, or the two arms of the angle A. If we extend any one of the arms outwards, the angle D that forms as a result is the exterior angle. You might say, why did I extend only this arm? I could have extended the other arm. Yes, we could. And we would get this angle that would measure the same. Similarly, if we can create exterior angles for B and C. Now, here are a couple of facts about exterior angles. Consider the exterior angle D. This angle, as you can see from your screens, this exterior angle D, the measure of this angle is equal to the sum of the two remaining interior angles, A and B. So, the exterior angle D is equal to A plus B. Another important fact is that if we sum up all the exterior angles of a triangle, then the sum total is 360 degrees. So this is a fact that you can just memorize. The sum of the exterior angles is 360 degrees, whereas the sum of interior angles from the last slide was 180 degrees. And another nice fact is that this fact about the exterior angle doesn't just apply to triangles. It also applies to other shapes like a square, rectangle, a pentagon, hexagon. In fact, any polygon, the sum total of their exterior angles is 360 degrees. So let's remember this fact. Okay, now that we know the basics about triangles, let's get going with some of the important laws. So the first of them is the so-called Pythagoras theorem. First of all, remember that the theorem only applies to right-angled triangles. That is, a triangle with one of its angles equaling 90 degrees. Now, to apply this, first thing is picking an angle. Let's consider the angle A, which is marked out in this slide. So it is at the corner A. So once we have identified the angle, after that we can start marking the names, or we start labeling the names of the side. So the side opposite to angle A is named as opposite. Surprise, surprise. The side adjacent to angle A is called adjacent. Again, I hope you can see the logic in that. The last remaining side is hypotenuse. So I hope that's not too difficult to remember. Now, another convention is because these sides are opposite to angles A, B, and C, they are also named as the lowercase a, b, and c respectively. So once we have agreed on this naming convention, the Pythagoras theorem is already on your screen, and we read it like this: hypotenuse square equals opposite square plus adjacent square. Or we can call them c square equals a square plus b square. Now be careful when we're calling them a, b, and c. You ought to remember what a, b, and c represent. Now we can use the Pythagoras theorem to work out the missing sides of a right-angled triangle. For example, if we know side A equals 4, B equals 3, then we can find the side C, or hypotenuse pretty easily. So we use the identity c square equals a square plus b square, and c square turns out to be 25, and then we take the square root on both sides, and hence c equals 5. So I hope that's straightforward enough. Now, for a right angle triangle, we can also define certain other rules as well. So we can work out the ratios of the sides of a right angle triangle. And we have special names for these ratios. For example, sine of angle A equals the ratio of opposite and hypotenuse. Similarly, cosine or cos of angle A equals ratio of adjacent and hypotenuse. Similarly, tangent or tan of angle A equals the ratio of opposite and adjacent. Now, to remember these ratios, people have invented their own various techniques. One often taught at schools is on your screen. For instance, sine is remembered as saw. So S stands for sine, O for opposite, H for hypotenuse. Similarly, cosine or cos is, you may call it ca. So you can work it out what ca stands for. And similarly, tan is, can be remembered as toa. So, this is just one of the tricks that applies. If you have some better ones, please feel free to practice it. But important thing is practice repeating it to yourself so you don't forget what they mean. Also note that the labels opposite and adjacent depend upon which angle you choose. For example, if we choose angle B, then the opposite and adjacent shift. So you can just pause the video here and just look at it. The opposite is still opposite to angle B, but its location has shifted compared to the previous diagram. Hypotenuse, though, is the longest side in a right angle triangle, so it still stays the same. But remember, these definitions work for a right-angled triangle only. So don't use them to work out angles or side lengths of other triangles. So what can we do to work out the sides or angles of other triangles that are not right-angled triangles? Well, we can apply some rules, and one of them is the so-called sine law, and it's written on your screen. Suppose for a non-right angle triangle, we know two side lengths, A and B, and we also know an angle A, which is 30 degrees, and our job is to find the angle B. So we can use sine law to figure this angle B. However, before we do that, remember lowercase a must be the length opposite to the angle A. We must follow this convention with other angles as well. If we don't do that, we can get the sine law all mixed up. So we just use, because we have angle A given and we have sides A and B given, we can use part of this sine law, which says sine of A over small a equals sine of B over small b, and we can, fill in the value. So because A is 30 degrees, so we have sine of 30 over small a, which is 4, and angle B we still don't know, so we leave it as sine of B, and divide by small b, which is 3. And we just use a calculator, or if we remember sine 30 off the top of our head, we can fill the values in, and we make sine b the subject of this equation. Again, if you don't know how to make a subject of an equation, you can look back on this on the video of how to make a subject. So sine b is 3 times sine 30 over 4. And then we, like I said, we can use a calculator and fill in the value of 30. And then we get, the answer is 0.375. Now we still have got sine of angle B. Now what is angle B? For that we use another function called sine inverse. So you can look at your calculators and there may be a button for sine inverse, or and sometimes you have to press a shift button first and then the sine, and you can work the sine inverse. So sine inverse is the opposite of the sine, and if you do sine inverse of 0.375, you will get the angle B as a result. Finally, the cosine law is another one that applies to any triangle. So in this law can be used if we have only one angle given and we also know the two sides around it as well, and then we can find the side length opposite to angle A. So in this case, the formula, the cosine rule is written like this. So a square, A is the length opposite to angle A, equals to B square, which is another side length, plus C square, which is another, side length, minus 2BC and cosine of the angle A. So if you look at it, you can repeat it easily, but it's not that hard to remember. So A square is the side that we want to figure out. The remaining two sides are given, so we can use B square plus C square, and minus, we multiply them, and cosine of angle A. So all these things must be given, and then we can work out the length of the side A. Similarly, but this is not, we are not limited to just length A. We can also work out for B, for other lengths. So B square is just very similar. So we want to figure out the length of B. We pitch in the other lengths and we use the angle given. So, and similarly we can do it for C. So remember, in these formula, the angle given is the trapped angle. For instance, angle A is trapped between the lengths B and C. And once that is the case, we can work out the length A. Similarly, in the second case, angle B is trapped between A and C, sides A and C. You can see it on your screens. And angle C is trapped between sides B and A. So remember, the angle that we use in cosine law is always the trapped angle. The same formulas can be rearranged this way as well. So in this case, we have made the cosines as the subjects of the equation, and we've just rearranged the same formula. So these are not new formulas, they are just the rearrangements of the formula. So we can use this to work out the cosine of these angles. And just like there's the sine inverse, there's also a cosine inverse that's available from your calculators. Once you work out the cosine of A, for instance, then you can figure out A by taking the cosine inverse of the value that you've got. And that's how you get the angle A. So with that, we come to a conclusion of this discussion of triangles. Hope it made sense. Please feel free to go back to the parts of the video that you didn't understand, or go back to earlier videos if you want to look at more fundamental concepts. Thank you.